I was even trying to identify where the comet is, which dot is the comet, prior to November. But after perihelion, after it passed through the sun, or get closer to the sun and came out, we started actually able to observe this comet because it started getting slightly brighter from our visual standpoint.
An independent astrophotographer named Ray just posted something that changes everything we thought we understood about 3I Atlas. He's been tracking this object every clear night since early November with his backyard telescope. And he caught it doing something comets aren't supposed to do. It's flickering, turning on and off like someone's flipping a light switch, not gradually changing as it moves through space, not slowly dimming as it gets farther from the sun, cycling between completely different states. Active, dormant, active again, dormant again. Sometimes over days, sometimes within hours. This video is made possible by Ray's astrophotography. All the observations and data you're about to see come from his tireless work tracking this object night after night. Make sure to check out his channel, subscribe, and support the dedication he's putting in. Link is in the description.
So on November 5th, it was tiny after the perihelion. It is like this small. I have to run through the programs to figure out, in fact, this is a comet, right?
Ray started tracking 3I Atlas on November the 5th, right after the object passed perihelion. Perihelion is the closest point to the Sun in a comet's orbit. That's when comets are supposed to be at their brightest, because solar heating is at maximum. As comets move away from the Sun after perihelion, they should gradually dim down. Activity decreases steadily over time. It's smooth, predictable physics. The farther you get from the Sun, the less heating you receive, the less ice sublimates, the dimmer the comet gets. Ray's setup was consistent. Same telescope every clear night. Same camera, same filters, same processing software. He controlled for all the variables, so he could track real changes in the object itself, not changes in how he was observing it. What he expected to see was normal comet behavior. Steady decline in brightness as 3I Atlas moved away from the Sun. Gradual decrease in activity over November and December. Standard physics following the pattern we've observed in thousands of comets. What he saw instead was completely different. Ray's own words. Every time I look at the data is looking different. Not gradual changes, dramatic switches between states. And he says, something is definitely there which is making it turn on. Let's walk through what he captured. This is Ray's image from November the 5th. Look at how small it is, just a tiny blob barely visible in the frame. Ray says he had to run through his processing programs just to confirm this was even the comet. This is right after perihelion, when it should be at peak brightness. Instead, almost nothing there. Here's November 11th, 6 days later. You can see it's slightly better now. There's a small disk visible with some faint jets extending out, but still minimal activity for a post-perihelion comet. Ray's reaction when he captured this, it's not much you can clearly see. Now look at this. This is November 16th, just 5 days after that last observation. Everything turned on. You're looking at an extremely bright comet with jets shooting out in multiple directions. See all those colors across the coma? Green, blue, red, yellow. Each color represents different molecules being released. Green comes from diatomic carbon and cyanogen getting excited by solar ultraviolet light. Blue indicates ionized carbon monoxide, which requires higher energy conditions. Red suggests dust scattering or hydrogen alpha emissions. Yellow comes from sodium or other metallic compounds. When you see multiple colors like this appearing simultaneously, it means complex outgassing happening from multiple active regions at once. Different spots on the nucleus releasing different materials. Some areas venting carbon-rich gases, others releasing ionized compounds, others kicking up dust. This is an active, energetic state with a lot happening all at once. Ray thought when he captured this that this was the real state of the comet, that this brightness level would persist, that he'd finally caught 3I Atlas in its true active form, that future observations would show similar activity levels, maybe gradually declining but staying in this general range. That's not what happened. This is November 26th, 10 days after that bright explosion. Back to looking like a regular comet. You're seeing that classic green hue, steady glow, cone-shaped tail. All the extreme activity from November 16th is gone. Ray describes this as looking like any solar system comet that we normally see. Nothing unusual, nothing weird, just a comet. Here's December 2nd. The colors are back. You're seeing rotating structures now, complex features visible across the coma, multiple emission regions active again. Ray says when he processed this data, this is not the same comet as what we are seeing before. It turned back on. This is from yesterday morning, December 8th, when Ray captured this footage. You're seeing spinning structures, bright emissions, active features across the frame. Ray's comment, so much happening. High activity state with lots of detail visible. And this is from yesterday evening, same day. Look at the difference. Back to regular comet appearance. The active features from just hours earlier are gone. Ray's reaction when he processed this. To my surprise, I'm looking at a regular comet right there. It changed states within 24 hours. 6 observation sessions spread across 5 weeks. 6 completely different appearances, not gradual evolution where you'd see steady change over time. Cycling between distinct states. Off, slightly on, fully activated, normal, activated again, then toggling within a single day. And Ray's genuinely puzzled by this. His words, "The look and feel of the comet is completely different, depends on, I guess, the day we are looking at." Why this breaks the rules? Here's how comet activity is supposed to work. When a comet approaches the sun, solar heating drives everything. Ice on the surface and just below it turns directly from solid to gas. That process is called sublimation. The gas vents outward, carrying dust particles with it. That creates the coma, the fuzzy cloud around the nucleus. It creates the tail streaming away from the sun. Activity gradually increases as the comet gets closer to the sun because heating increases. It peaks at perihelion when the comet is closest and heating is maximum. Then activity gradually decreases as the comet moves away and heating drops. It's a smooth curve up and a smooth curve down. This happens because solar heating is predictable. The sun doesn't flicker. Solar radiation is constant. The amount of energy a comet receives depends only on its distance from the sun. There's a law for this called the inverse square law. Double your distance from the sun, you get 1/4 the heating. Triple the distance, you get 1/9 the heating. It's math. It's physics. It's reliable. By November and December, 3I Atlas is moving steadily away from the sun after passing perihelion in late October. Distance is increasing every day. Solar heating is dropping every day. The object should be in steady decline. Less activity each week. Dimmer each observation session. What Ray's footage shows instead is the object at roughly the same solar distance showing completely different states separated by just days. November 16th and November 26th are only 10 days apart. In that time, 3I Atlas moved from about 1.13 astronomical units to 1.19 astronomical units from the Sun. That's a tiny change in distance. Solar heating barely changed at all. Yet, one observation shows extreme activation with multiple colored jets and complex emissions. The other shows normal green comet appearance with steady, quiet glow. The sun didn't change its output. The distance barely changed. The object changed. Think about what this means. Between November 16th and November 26th, Solar conditions were essentially identical from the comet's perspective. The sun was putting out the same amount of energy. The comet received nearly the same intensity of solar radiation. The heating that drives sublimation barely changed. The environment around the comet was stable. Yet the comet's behavior wasn't stable. It went from full activation to quiet dormancy. That's not a response to external conditions changing. That's the object itself changing how it responds to those conditions. Something internal is varying, not something external. And then there's the December 8th problem. This is the one that really doesn't fit any explanation. Morning observation shows high activity, spinning features, bright emissions, complex structures visible across the coma. Evening observation, less than 24 hours later, shows dormant comet. Regular appearance, all those active features gone. Once you release gas and dust into space, it doesn't vanish in hours. The coma is a cloud of material extending hundreds of thousands of kilometers around the nucleus. When a comet vents material, that cloud persists for days as it slowly disperses. Solar wind and radiation pressure gradually push it away. But it's a slow process. Instead, Ray captured a clean shutdown. Active in the morning, dormant by evening. How does ejected material disappear that fast? What mechanism allows that kind of rapid state change? There's also the chemical signature confusion that ties into this. Early spectroscopic studies of 3I Atlas found no hydroxyl and no cyanogen. Those molecules are what define comets. Hydroxyl comes from water ice sublimating. Cyanogen comes from organic compounds. If you don't detect these, you're not looking at a normal comet. The early papers said 3I Atlas appeared chemically inactive, almost like an asteroid, not a comet. Then after perihelion, Japanese X-ray satellites detected emissions from the object. Those X-ray signatures require cometary gases to exist. You can't produce those X-rays without molecules like hydroxyl in the surrounding cloud. So which is it? Active or inactive? Comet or not comet? Ray's flickering documentation suggests the answer is both, depending on when you look. The signatures appear and disappear based on the object's current operational state. Ray has his own hypothesis about what might be happening. He points out that 3I Atlas is an interstellar comet. It didn't form in our solar system. It came from another star system. It's been traveling through interstellar space for millions or possibly billions of years. That entire time, it was exposed to intense cosmic radiation. Interstellar space isn't empty. It's filled with high-energy particles, cosmic rays, radiation from distant stars and supernovas. Material gets bombarded constantly out there. Ray's words, "I don't know what happens to any material once it got exposed to heavy dose of cosmic rays for such a long time. Maybe when that altered material comes into our solar system and interacts with our sun, something activates that we don't understand. Different chemistry than we're used to. Different reaction to solar heating." Ray says, "We don't know the chemical composition of this comet for sure, and what is turning on and what is turning off. To give you some context on why interstellar origin matters, consider what these objects go through. In our solar system, comets spend most of their time in the outer reaches, in deep freeze. When they swing close to the sun every few decades or centuries, they warm up briefly, outgas, then freeze again. That cycle repeats, but the material doesn't fundamentally change. Interstellar comets are different. They form around a different star with different chemistry. Then they get ejected somehow, probably through gravitational interactions with giant planets. Once they're in interstellar space, they're exposed to cosmic radiation continuously for millions of years. High-energy particles slam into the surface atoms. Chemical bonds get broken and reformed. New compounds can form that wouldn't exist in a normal solar system comet. When that altered material finally enters another star system and gets heated again, we don't really know what happens. We have theories, but very little data. 3I Atlas might be showing us what happens when cosmic ray-altered material reacts to solar heating for the first time in eons. That's one possibility. Here are others. Maybe this is rotation-dependent venting. Maybe 3I Atlas has active regions on only one side of its nucleus. As the nucleus rotates, those regions face the sun and heat up. Ice sublimates, material vents out. We see high activity. Then those regions rotate away from the sun into shadow. They cool down, venting stops, activity shuts off. The problem with this explanation is it requires rotation timing that perfectly matches Ray's observation windows. He's not observing continuously. He captures data over a few hours, then days pass before the next observation session. For rotation to explain the pattern, active regions would need to be facing the sun during some of his sessions and facing away during others, and it requires all the activity to come from very localized spots. When those spots face away, the entire object needs to look dormant. That's extremely specific geometry, not impossible but very unlikely. Another possibility is subsurface pressure cycling. Maybe there are sealed chambers or pockets beneath the surface. Gas builds up pressure over days as ice slowly sublimates. Eventually, pressure gets high enough that the chamber ruptures. Material explosively vents out. Then the chamber reseals, pressure builds again, and the cycle repeats. This happens with geysers on Earth. Old Faithful in Yellowstone erupts on a predictable schedule because of subsurface plumbing and pressure cycles. But Old Faithful has geothermal heat driving the process. Underground chambers are heated by volcanic activity. That heat constantly converts water to steam, building pressure until eruption. Comets don't have internal heat sources. They're frozen chunks of ice and rock. Once you're far enough from the sun that surface heating stops, there's no mechanism to keep building pressure inside. What would drive multi-day pressure cycles in a frozen nucleus coasting through space? Maybe it's something we just haven't seen before. Ray's careful with his language. He says, "I don't think this is happening intentionally." But he acknowledges we need to look at this differently. His words, "We need to look at this as a comet, but may not be a solar system comet." Different star systems have different chemical compositions, different ratios of elements, different mixtures of ices and rocks and organic compounds. A comet that formed around a star with very different metallicity than our Sun might have chemistry we're not familiar with. Add billions of years of cosmic ray exposure, and maybe you get material that reacts to solar wind in ways we've never observed. We don't have a framework to explain it yet, because we've only studied 3 interstellar objects. Oumuamua, which left before we could observe it properly. Borisov, which looked fairly normal. And now 3I Atlas, which is showing behavior that doesn't fit our models. But none of these explanations really handle the December 8th observation. Rotation can't cause state changes that happen in less than 24 hours, unless the nucleus is spinning every few hours, which seems extremely fast. Pressure release can't make ejected material vanish overnight. The coma should persist even after venting stops. Something allowed full activation, followed by complete shutdown within a single day. What mechanism does that? Here's what we know for certain. Ray has documented systematic, repeatable flickering across 5 weeks of observations. Same equipment every time. Same methods. Controlled observations accounting for atmospheric conditions and processing variables. This isn't an artifact. This is real behavior from the object. The flickering pattern doesn't correlate with solar distance. It doesn't follow the smooth activity curve that normal comets display. It doesn't match rotation models unless you assume very specific, unlikely geometry. Chemical signatures appear and disappear based on whatever state the object is currently in. Here's what we don't know. What triggers the activation cycles? What causes the shutdown? Whether there's a predictable pattern or schedule to when it turns on and off. Whether this behavior is unique to 3I Atlas or common to interstellar comets in general. We just don't have enough data yet. Why does this matter? Because this is the first interstellar object we've been able to track this extensively through its perihelion passage. Oumuamua was discovered on its way out of the solar system. By the time we realized it was interstellar, it was already leaving. We got limited observations before it disappeared. Borisov, we tracked better. We caught it on the way in, followed it through perihelion, watched it leave. But Borisov looked fairly normal. It behaved like solar system comets. Its chemistry matched what we expected. There were a few oddities, but nothing that broke our models. 3I Atlas is different. It's showing behavior we can't explain with current comet physics. Either this is a completely new natural phenomenon we're documenting for the first time, or we need to seriously expand our understanding of what comets can do. Ray's continuing his observations. He's tracking through December 19th, when 3I Atlas makes its closest approach to Earth. It won't be particularly close, about 269 million kilometers away, but close enough for detailed observations from multiple telescopes. Ray's building more data on the cycling pattern, trying to identify if there's a schedule or trigger he can pin down. Every clear night, more observations going into the dataset. If you want to follow this story as it develops, check out Ray's astrophotography channel. Link is in the description below. This is real data from an independent observer with real equipment, not speculation or theory. Documented photographic evidence collected systematically over weeks. He's posting regular updates as 3I Atlas approaches Earth over the next few weeks. This is how science actually works. Independent researchers documenting unusual observations. No institutional pressure, no narrative to maintain. Just, here's what I'm seeing. Here's the data. Here are the questions it raises. And right now, the data shows an object that flickers, that turns on and off in ways we can't explain yet. So, what do you think is causing this behavior? Is it rotation? Internal pressure cycles? Something about its interstellar origin and cosmic ray exposure that we don't understand? Drop your theory in the comments. And if you want to stay updated on 3I Atlas as it makes its closest approach in the coming weeks, hit subscribe and turn on notifications. Ray's next observation session could answer some of these questions, or it could raise even more. Either way, we'll be here covering it. Make sure to support Ray's channel. This is the kind of independent observation that pushes science forward. Real data, real questions, real mystery.